Hi everyone, we are excited to have you here in today's fun-filled learning session at Uolo. Here is a quick look at how you can submit your work after the class. As a first step, go to live.uolo.com. You can use any browser to access this site. On this page, you will see a list of all our classes. Scroll down and you can see the Submit Your Work button. And then you will see a list of the classes that you've last attended, which could, for example, show the dance or craft or science experiment classes you've attended recently. Next, it will show you the list of children whose names are registered in this mobile number. Choose your name from this list to submit your work. For instance, if you are Satvik Kumar, choose that name. And then choose the class for which you would like to make your submission. For example, if you've attended the New Year's Masquerade Party session and you'd like to make the submission for this class, click on the Submit Your Work button below that. And then upload the photo you've taken. Choose the image from your phone and click Submit. You can scroll down and view all your past submissions and see how many of your friends or peers have liked your work. You can also see others' work and like their work to inspire your friends. If you want to showcase your work on social media, that too is very simple. Click on Share, copy the link, and post it on Instagram or Facebook or any other platform of your choice. Just a tiny reminder, your submission looks a lot better if you could click a photo in the landscape mode rather than the portrait mode. Do not forget to tag us at YOLO_app. I'm eagerly looking forward to all your submissions right after this class.
Hey there, kids. How are you doing? Welcome to today's class. Today is the last class of our universe course that we have here going on at YOLO, and I am so excited to have you here with me today. Now, in the previous classes, we went ahead and spoke a lot about the universe, and we spoke so much about, how it is basically like. So, the first class, we went ahead and spoke about how the universe basically evolved. The second class, we went ahead and spoke about a few mysteries when it came to the universe. The third class, we went ahead and spoke a lot about the different elements in the universe that exist, but we don't really know about it. We spoke in detail about it, and in today's class as well, we're going to be going ahead and talking about the other elements that exist in the universe that we don't really know about. Now, I hope you had a good time in the last class, though I didn't go ahead and host it. I hope you learned quite a bit. In today's class, we're also going to go ahead and learn quite a bit. I am so excited to take you further, explore a lot more when it comes to the universe. It is something that I feel every child should know at whatever age they are at some point of time. They should be introduced to it. At some point of time, they should be encouraged to learn about it, and then you can figure out whether you want to take this research further, when you want to go ahead and study it further. Now, in my first and my second class, if you remember, I was talking to you a lot about how there are certain theories as to how the universe basically came about, and I also told you about how talking about these theories and knowing a lot about these theories will give us the opportunity to figure out whether we want to know more about it, and maybe one day will go ahead and do more about it. It's the same thing when it comes to the last class as well as today's class. It is about talking about the information we know about a particular thing out there in the universe with whatever study we could go ahead and do, but obviously there is a lot more that we still don't know about. So it's basically talking about that, discussing about that, talking about how much we know and giving you an idea that this is the information we know. Maybe tomorrow you will be someone who will be interested in going ahead and learning further, or maybe you will go ahead and keep yourself updated if there is any further information or news or anything that's basically going ahead and developing in this spectrum of things. Now, since you've spoken a lot about this, let's go ahead and talk about your certificate program as well as your submissions. Now, coming to your certificate program, like you all know, you're getting certificates for the work that you're already going ahead and doing. All you have to go ahead and make sure of is firstly that you are attending all of your classes. So again, if it's a 4-part course, for example, this one is make sure you're attending all of the 4 classes. If it's an 8-part course, then you will have 8 classes to attend. Now, coming to your submissions, you will have a submission every single class. So I hope you're going ahead and doing all of your submissions on time, because that as well will automatically end up giving you the certificate right at the end. Now, the courses are planned a certain way, right, for you to learn the most, to make the best out of it. So make sure to follow through, right? We want you to learn. Now, coming to your submissions, irrespective of what class you're attending, whether it's this class, whether it's a dance class, whether you're doing an art class, whatever it is, when it comes to our website, I hope you're going ahead and taking part in doing all of your submissions, because like you all know, we want to focus on one thing, which is going to be improvement. We want to go ahead and focus on how you are growing as an individual. So the only way we as teachers can assess that is by looking at your submission. So make sure you're going ahead and doing a good job when it comes to your submission, and doing it like on time, so that we can see the growth. Now let's go ahead and get started with today's class. So the first element of the universe that I want to go ahead and talk to you about is a comet. So what you see right in front of you is basically a comet. If you look at the shape of the comet, it's basically sort of like a circular sort of ball. So if you look at it, it's almost like a circle, probably like an oval, sort of like, in that wavy format, like a big rock probably. So that's kind of the size, how the shape of the comet is. And now the comet can basically transform into what you are seeing right now. So that explanation I'll give you later. But basically, when it comes to the form of the comet, it's basically like a circle. Now it can exist without this kind of long glowing tail it has, or it could exist with the long glowing tail it has. Now let's first talk about what a comet is. A comet is basically all the leftovers of when the solar system was being formed. So when the solar system was being formed, like I told you, you had the planets that got formed, you had the rocks, you had the sun, you had the moon, you had all of that, right? You had the stars, everything basically got formed. So one of the things that basically got left over were things like gases, we had dust, we had ice, we had rocks, all of that kind of was floating together. So what basically happened was all of that kind of came together and became one sort of round kind of a thing, and that became a comet. So that's basically how comets are formed. So what are comets then? Like we already established, it's something that is, the leftovers. We spoke about the elements that it's made of, like dust, ice, all of that. But basically, what is it in general? It's basically something that's sort of like a frozen material that is, kind of compacted all together. So whenever something is frozen, it kind of, snowballs together and becomes like one big giant rock. And it basically is part of our solar system. So it orbits whichever star is there. Now, if you're looking at our solar system, we basically have the sun. So it orbits the sun. So, for example, we have Earth, we have Mars, we have Venus, we have Mercury, we have all of these planets that we have. In the same format, the comet also basically orbits the sun. So it just basically moves around. Now, what about the size of the comet? Now, the size of the comet is basically as big as the size of a small town. So let's say you are currently living in Bangalore, then probably it's almost probably one fourth the size of Bangalore in terms of how big the comet could generally be. So this is basically when the comet is completely frozen, it's this big. Now comets can basically go ahead and have changes in them. So what kind of change could basically happen? Now, like you all know, the comet is kind of circulating the orbit of the sun, but comets also sort of move closer, closer, closer to the sun as the time basically flies by. And as it basically moves closer and closer to the sun, what basically ends up happening is that the comet starts heating up because the sun is really hot, right? So when something frozen and something hot comes together, the frozen thing will basically start melting. So when the frozen part basically starts melting, all of the gases, all of the things that are basically there in the comet become really, really hot, and the comet starts expanding. So when it starts expanding, then it becomes really, really big. It becomes even bigger than the planet of Earth, it becomes bigger than the planet of Venus, it becomes bigger than the planet of Mercury, because it's heating up all the gases on the rocks or the burning, it's getting really, really, really hot. Now, as it's becoming hot, it moves into being sort of like a circular object with a big tail. The tail is basically away from the sun, so it'll be probably moving towards the sun and it's away from the sun. So if you ever basically look at a comet from, like from Earth, then you will be able to look at it as something like a big star, like a shooting star that is kind of, running across and going across. So that's basically how a comet looks like. Now, how many comets are basically there outside? How many comets are basically there out there in space? Frankly, it is unknown. Obviously, comets keep, getting formed, obviously as gases and things like that keep coming together, the comet keeps getting reoccurring and forming and forming. So right now, there are so many comets that we've basically gone ahead and seen. So some examples of the comets are basically the Hartley comet, the Borrelly comet, the Halley's comet. We have the Borsuk comet. Then we have the Temple One comet. We have Ison. We have Sliding Spring. We have so many comets that people have gone ahead and seen. It's basically kind of passed across Earth's surface. You could see basically it's obviously far away from Earth's concept, but you can go ahead and see how it's basically flying. So this is basically the concept of a comet. So the next element that I want to go ahead and talk to you about is called the magnetar, or these are called the magnetic magnetars. Now, what a fantastic name, isn't it? It's so fascinating that I'm going ahead and talking to you about it. So firstly, what are magnetars? Magnetars are basically a form of stars. They're a form of neutron stars. Now, I think we've gone ahead and spoken about what neutron stars are in the last class, so I will not dwell into it. But basically, it's a kind of a neutron star. Now, what you're looking at, and the picture right now that you're looking at, it's basically this is a magnetar star. You can see the kind of waves and the designs, the patterns that are there. You can see the kind of solid mass that it has right there in the center. So this is basically the magnetar or the magnetic magnetars. Now, what basically is the magnetar? Like I mentioned, the magnetar is basically like a simple neutron star. But what makes it different from normal stars or neutron stars, or what is the whole concept behind it? So basically, magnetars have an extremely strong magnetic force. Now, you do know that most stars do have a magnetic force, even planets as well. They do have a magnetic force that basically creates the concept of gravity that basically keeps things together, right? But magnetars tend to have a very high level of magnetic power, more than what most stars have, more than what most planets have. So they tend to normally say that it has about 1,000 times stronger than any normal neutral star. So if you go ahead and take the sun, then the sun may be at 1%, but a magnetic star or a magnetar star will be at 1,000%. So that's quite a big range of how different it can go ahead and be. Now, if you're going ahead and comparing it to the Earth, then the magnetar's magnetic force is about 1 trillion times stronger than the Earth. So think about the force that's basically there. Now, magnetars are hence very intense, in terms of stars. They are not very subtle or simple or smooth in general. They are really strong and powerful when it comes to being a star. Now, if you venture anywhere close to a magnetar, let's say you go 1,000 kilometers close to a magnetar, the field of the magnetar is so powerful, you will immediately get sucked in, which is kind of destroying whatever goes close to it. So if you're a human being, if you're a star, if you're if you're a planet, or if you're a comet, or if you're a rock, what will happen is it will kind of suck you right in because of how strong the magnetic forces basically are. Now let's go ahead and talk about more when it comes to the magnetar. Now the magnetar tends to also go ahead and release a lot of gases. Now obviously it is magnetic, but it also tends to release a lot of gases. For example, it releases X-ray gases, it releases gamma ray gases. It's very similar to that of a black hole that has a lot of very kind of extreme gases that we as human beings cannot basically go ahead and face a lot. So it is something that gives this whole thing. Now, what basically gives the magnetar its magnetic power? Now, in general, when people have gone ahead and done research about where the magnetic forces comes from, or where the whole thing of gratitude, like the whole thing basically comes from, the whole magnetic force basically comes from, it's basically the concept of what makes the interior of the star. Now if you're looking at the sun, or if you're looking at the earth, it's basically how the internal gases, the rocks, all of that are gives the basic magnetic force, right? So in the same way, this star will have these kind of interiors that create such pull and such force. Now this I'm basically explaining in a very simple term. I'm not very explaining in a very complicated term, but obviously, there is a lot of gases, a lot of, elements that basically make the magnetar what it basically is. Now, when was the first time that a magnetar was ever identified? Now, the magnetar was first identified by the human civilization in 1979. Before that, they didn't really understand the concept of the magnetar, and they didn't really see a concept of the magnetar. So it was basically found by two Russian spacecraft. So they were the one who basically found out, and they were basically two astronomers who identified that there was something like this, who identified that there was such strong pull and a magnetic force coming out of a particular thing, but they couldn't figure it out as to what was it. They obviously predicted it to be different things, but eventually they did a lot of research on it. They figured out what kind of rays were there, what kind of forces it had, and they figured out that it's a magnetar, and hence the basic name basically came about of it being a magnetar, or basically a magnetic star. So the next element that I want to go ahead and talk to you about is a blazer. Now, a blazer is not actually an element. It's sort of like an idea or a composition or something that's sort of part of the universe out there. I can't really put a name to it. Probably it's not an element, but basically the blazer is something really fun and interesting to talk about, and hence I wanted to go ahead and include it in today's class. Now, what is the blazer? Now, blazer is basically what you go ahead and see right here. Now, if you've gone ahead in the last class and paid attention and saw what a black hole is, then you will know what a blazer is. Okay, so it's very similar to that of a black hole. Now, if you've read up on the black hole, or in the last class when we went ahead and spoke about the black hole, you do know how the black hole is sort of something that sucks, things into it, right? It's something that is an active galactic nuclei that basically goes ahead and sucks a lot of things in. It has a lot of energy. It basically goes ahead and takes a lot of things in, right? So basically a blazer is a kind of a form of a black hole, or it's basically a result of a black hole, or probably a consequence of a black hole. So if you look at the composition of what a blazer is like, then it normally basically is sort of like a circular spiral thing that we have here like this, with a center nucleus, which is basically the black hole, with a lot of light basically coming on either side. Now, what is the formation of this exactly? Now, the blazer basically is formed in a galaxy. So if you've ever gone ahead and seen the Milky Way, it's basically a galaxy. So whenever you have circular galaxies or spiral galaxies or oval galaxies, what happens is there'll be always a center, which is the center eye. And the center eye is normally a black hole. So the whole, galaxy or the Milky Way, whatever it is, circulates sort of around a black hole. So what happens is, if you're going ahead and from Earth looking at a galaxy like this from a very far distance, because so much of sucking is happening of energy, so many like elements and things like that, a very large light is sort of illuminated out of it. A whole light is kind of created out of it, and this kind of comes out from both of the directions. So what it basically looks like is that from within the black hole, there's a huge emergence of basically light coming in. So if you look at this right now, you can see the center is basically black, but it looks like there's a huge immersion of light basically coming out from one direction. So basically that is the blazer. It basically looks like there's like light blazing out of a galaxy. So this basically happens in galaxies, and we basically can see it only in far off galaxies, because you need to be at a certain distance to kind of see the blazer or the effect of a blazer. So it's basically just a concept of when black hole is kind of sucking things in, it is kind of the consequence or the result of so much energies being passed on, that it creates light and this kind of illuminating thing. Now look at how beautiful it is. It looks so fascinating, and it's something that I really wanted to go ahead and talk to you about. The next element that I want to go ahead and talk to you about is basically an asteroid. Now, asteroid has been something that's kind of been confusing with scientists and with astronomers and all of those people. They've basically researched this time and again, and they've actually gone ahead and classified it to be one thing, and then later moved on to being another thing. Now, basically, the picture that you see right in front of you, that is basically an asteroid. It's kind of like a really large rock that basically does have an inner core. It has layers to it, and then it has sort of like an outside layer. Now, asteroids can basically vary in terms of size. It can be really, really large asteroids or can be smaller asteroids as well. But asteroids don't tend to be as large as planets. They tend to be much smaller than planets in general. Now, what is an asteroid, right? What does it basically mean? Now, initially, when they did research on asteroids, they felt like it was something similar to a comet, but basically, it wasn't a comet in general. Because what happened was when they did research, they figured out that it is not something that's frozen. It's basically solid and it is basically occurs with lava, rock, everything basically exists on it. So, it's not necessarily something that's frozen. Also, whenever an asteroid came very close to the sun, it didn't really start melting or blow up or didn't end up having a tail. So it hence could not be classified as a type of comet. So hence it was something else altogether. Then what they decided was that it was probably just certain things that kind of circulated, like big rocks or chunks that circulated in the orbit of the solar system. So then they classified asteroids to be something like that. But over time, as they did research and study and things like that, they realized that asteroids are actually small planets. They're really, really, really tiny planets that basically exist as part of our inner solar system. So if you go ahead and look at Jupiter's orbit, co-orbit, then you will notice that there's a whole line of asteroids that are basically there. So these are all tiny, tiny, tiny planets. Now, obviously, you cannot be classified as a particular planet because it doesn't have like such a big structure, doesn't have moons, doesn't have everything. But basically, it could have been formed into becoming a big planet, but something happened and it did not become a big planet. So asteroids are sort of like almost a planet but not a planet, and hence they are called as minor planets. Now obviously with the research, a lot of and different things can basically come up when it comes to asteroids. But one thing that they have figured out is larger asteroids are basically called planetoids because they're almost a planet, but they're still not. So they could also be classified as sort of dwarf planets. For example, what Pluto was, it's kind of a dwarf planet. It's a smaller planet, but it's not classified as a planet yet. So somewhere on those lines is what an asteroid basically is. The next element that I want to go ahead and talk to you about is basically an exoplanet. Now, if you look at your screen right now, you can basically see that we have Earth on one side, and then we have something called the Kepler 1649c. Now, the 1649c Kepler is basically a exoplanet. So what is an exoplanet? First of all, let me explain it to you. So the exoplanet is basically an extrasolar planet or an exoplanet, which is basically a planet that exists outside the solar system. So obviously we have the solar system and we have probably 7 to 8. Now depending on whether you consider Pluto to be a planet or not, we have 7 to 8 planets that we have as part of our solar system. Now in accordance to that, it's basically they orbit the sun, and we basically have them. But what about all of the planets that exist outside the solar system? What do you basically go ahead and call them? Now, those are all the planets that we basically call as an exoplanet or an extrasolar planet. So these are basically everything that is outside our solar system. So, when was the first exoplanet ever noted? The first exoplanet was sort of noted in 1917, but it was not recognized as such. So, what basically happened was people identified that, yeah, there was a planet out there, it existed, but they didn't really put a name to it, they didn't really identify anything. They just went ahead and, kind of were like, okay, yes, there is something out there. But in the year 1992, with further research, and someone obviously took interest in it and figured it out, they confirmed the detection of there being an exoplanet. Now, following that, a lot of research was done behind exoplanets, and as of September 1st, 2021, there are 4,834 confirmed exoplanets, 3,572 planetary systems, and 795 systems that have more than one planet. So what do all of these numbers mean? It basically means that out there. There are 100% many systems out there, not just the solar system, but there are many systems that have more than one planet. And 100% that there are at least 4,800, approximately 4,800, 4,900 planets or exoplanets that exist out there. So our eight is not the only eight that exists. There are so many systems, there are so many suns, there are so many systems around it, orbits that exist, and planets that exist out there. So everything outside the solar system is basically called an exoplanet. The last element that I have here with me today as part of today's class is basically called the Prostar. Now, what is the Prostar? The Prostar is basically just another star, but it's a very young star. Now, like the sun is also a star. We have so many stars out there. But basically, by the time it becomes the sun, by the time it basically grows, it has such a big gravitational pull as it goes on, and has so many planets surrounding it and things like that. It has to form from somewhere, right? It has to develop somewhere. It has to have a certain amount of mass that it basically starts off with, and then becomes what it basically is. So a protostar or a protostar, like they call it, is basically a really young star that exists. It is sort of like a developing star. So if you go ahead and look at this picture that I have for you, the center brightest star that you see right there is a prostar or a protostar. So these basically stars are, slowly collecting molecules, slowly gravitationally pulling things towards it and becoming bigger and bigger and bigger. Now, obviously, it takes time. It lasts for about 500,000 years. A prostar's phase basically exists where it has a low density, low mass. It's just the beginning stages of a star, and as time basically keeps going on, it keeps growing and growing. And then surrounding it, you'll probably have planets that form, and then you'll have a galaxy that forms, and all of the systems that basically take place. But basically, the prostar is just the beginning phase of a simple star. Now, excellent job, everybody. You have done so well with this class. You've listened so well. You've been so attentive, so good in understanding what I'm going ahead and talking about. So I am really proud of you. Now, like I mentioned, today is the last class of this course. So I want to give you a really fun submission to go ahead and do. Now, this class's submission is going to be a very unique submission. So I'm going to give you options basically on what you can go ahead and do, and I would like for you to go ahead and pick out whichever you like. Now, today's class, I went ahead and spoke about 6 basic elements, right? I spoke about the blazer, spoke about the prostar, I spoke about asteroids, I spoke about comets. I went ahead and spoke about, still two more things I went ahead and spoke about. Now, before, thinking about anything else, I want you to think about this concept. I want you to think about this 6 types of things. So I want you to come up with an idea or a concept wherein you can go ahead and draw this. You can draw any of the elements that we've spoke about. That's option number 1. Option number 2 could be kind of making up a story of what could happen after this. So let's say we want to go ahead and talk about the prostar. So talk to me or write down sort of like a story of what the prostar could become. What could it attract? What could it mean? Some idea, some facts, some knowledge about it that you can go ahead and create up. Now you have options. Like I said, one could be a drawing concept, one could be an imaginary concept. So up to whatever you like, go ahead and think about it and come up with a concept to go ahead and draw out or write out. That's going to be your homework for today and your last submission for this course. I am so happy with how you've gone ahead and done in this course. You've been so patient, you've been so vigilant, you've been so good, and I am so proud of you for doing this well, right? All right, excellent job, everybody. So happy with how you've gone ahead and done. Now, like I always talk to you, get the certificate while you can. So attend all of your classes and do all of your submissions on time. Apart from that, I talk to you always about the importance of submissions. I talk to you about how important it is to go ahead and do your work on time, how important it is to go ahead and do all of your submissions on time, and automatically as a teacher I'll be able to see your improvement. So I will see you as part of the next course, whichever we go ahead and do. Till then, bye bye and see you then. Bye.
Hi everyone, we are excited to have you here in today's fun-filled learning session at Uolo. Here is a quick look at how you can submit your work after the class. As a first step, go to live.uolo.com. You can use any browser to access this site. On this page, you will see a list of all our classes. Scroll down and you can see the Submit Your Work button. And then you will see a list of the classes that you've last attended, which could, for example, show the dance or craft or science experiment classes you've attended recently. Next, it will show you the list of children whose names are registered in this mobile number. Choose your name from this list to submit your work. For instance, if you are Satvik Kumar, choose that name. And then choose the class for which you would like to make your submission. For example, if you've attended the New Year's Masquerade Party session and you'd like to make the submission for this class, click on the Submit Your Work button below that. And then upload the photo you've taken. Choose the image from your phone and click Submit. You can scroll down and view all your past submissions and see how many of your friends or peers have liked your work. You can also see others' work and like their work to inspire your friends. If you want to showcase your work on social media, that too is very simple. Click on Share, copy the link and post it on Instagram or Facebook or any other platform of your choice. Just a tiny reminder, your submission looks a lot better if you could click a photo in the landscape mode rather than the portrait mode. Do not forget to tag us at YOLO_app. I'm eagerly looking forward to all your submissions right